So continuing with operations of functions, we're going to multiply and divide here. So now I'm going to take our f of x and we're going to multiply this to g of x, which is over here. Use parentheses, it'll make that a lot easier. So f of x, we have x plus 2, and this is being multiplied to x squared minus x minus 6. So remember, distributive property, a lot of you may have heard the term FOIL. I don't necessarily like using that, but let's just go ahead and look at distributive property. So when we distribute, we are taking each term in one set of parentheses, and we're multiplying that to every term in the next set of parentheses. Well, this next set of parentheses in our case has 3 terms. We have a positive x squared, a negative x, and a negative 6. So I need to multiply this first term by all 3 of these. And then I'm going to repeat the pattern with my next term. So 2 times all 3 of these terms. If I would have had 3 terms in the first one and 3 terms in the second one, I'd have to do that 3 separate rounds and get 9 total terms. In this case, we're going to get 6 total terms. So these 2 being multiplied by these 3 will get 6 total terms. And then the last thing we'll do is combine any like terms we have and simplify. So let's go ahead and start. We have x times x squared is going to give me an x to the 3rd power. X times a negative x will give me a negative x squared. And then x times a negative 6 will give me a negative 6x. Then finally, we're going to take this positive 2 and we're going to distribute that to each term in the next set of parentheses. So positive 2 times x squared is going to give me a positive 2x squared. 2 times a negative x is going to give me a negative 2x. And then finally, 2 times negative 6 is going to give me a negative 12. So now all we have to do is try to clean this up, simplify, combining like terms, and that should be the last step. Here I have an x to the 3rd. That's the only one I have. I have no other like terms that I can combine, so I'm just going to bring this straight down. So x cubed, or x to the 3rd, is going to come straight down. Now here I have a negative 1x squared and a positive 2x squared. So when I combine these, a negative 1 plus 2 gives me a positive 1x squared. Then I have this negative 6x and this negative 2x. When I combine those together on a number line, I would get negative 8x. And then finally, our last term here, this negative 12, our constant that has no other like terms in here, so we're going to bring that straight down. You want to write this in standard form from largest exponent down to your constant. So as we multiply these, this would be our solution. So f of x times g of x would give us x cubed plus x squared minus 8x minus 12. Now, what about division? In some ways, division is easier, but there are some times where it's a little more challenging. So if you still needed that up here, you can pause the video and rewind. I'm going to go ahead and take a look at division problem. So our second example, dealing with division, we're going to take f divided by g of x. So we're going to divide these 2 together. The nice thing about division is you're just going to put your numerator in the top. So f of x, in our case, is going to go up here, x plus 2. And then we're going to have our g of x in the denominator, in the bottom. So x squared minus x minus 6. This is where factoring is going to be helpful. So if we were to factor this, let's go ahead and write this out next to it. We're going to have x plus 2. I can't simplify that anymore right now. But if I factor this, I need 2 numbers that multiply to give me a negative 6 that at the same time would add together to give me a negative 1. And so those 2 numbers would be a negative 3 and a positive 2. So 2 numbers will multiply to give me a negative 6. Negative 3 times positive 2 give me a negative 6. And at the same time, negative 3 and positive 2, when added together, get me a negative 1. Those are the only 2 numbers that will satisfy both combinations or both conditions. Now what we're trying to do is look for anything that can simplify. So in our case here, we have this x plus 2 at the top, and that can simplify or reduce with the x plus 2 in the bottom. And so those simplify to give us 1. And so our final answer of f divided by g of x is going to be 1, because there's nothing left on the top. It reduced out to be 1 over x minus 3. Now this is the answer, but you're technically not done. So a lot of times questions will ask you for domain restrictions. What is a value of x in the denominator that you cannot have? Because if I replace that value in for x, I would get a 0 in the denominator, and you cannot divide by 0. We have two options. What we're going to do is we're going to take our denominator, and we're going to take each factor of our denominator and individually set them equal to 0. So I'm going to take x minus 3, set that equal to 0, and I'm going to take x plus 2 and set that equal to 0. Even though we simplified x plus 2 out, you're going to learn later what that does graphically speaking as you get into higher levels of pre-calculus and calculus. Now, from here, when we solve, we're going to add 3 to both sides. So we get that x equals 3, or in our case, x cannot equal 3, because when x equals 3, 3 minus 3 gives me 0, and I can't have a 0 in the denominator. In the same way, after I subtract 2 from both sides, I get that x equals a negative 2, or again, in our case, x cannot equal a negative 2, because when I replace this x in the denominator with a negative 2, I would get 0. So the two values, the domain can be all real numbers from negative infinity to positive infinity, except x cannot be equal to negative 2 or positive 3. So technically, your whole answer has to include all of this. So your solution, when you reduce it, your answer is 1 divided by x minus 3. However, you have to add this caveat that x cannot be equal to 3 and x cannot be equal to negative 2. And those are what's called the domain restrictions.